We are back again live here at the command center of the JW Solar USA in Minnesota. Thanks for watching. Guys, this is what I have. A big box electrical panel is to be set up for all kind of stuff. I got some switches, I got some all thing, and maybe it's for starting motors and whatever. And I something here with like air thing, whatever, hose, was sitting right from this hole right here. And these guys were on this other side, fuses here. Your fuses, and these other guys came from here. So, I don't know what the box is for, but I end up buying this box. It cost me only, what, $17. I said I have a plan for this box and I'm going to utilize it. What I've done, if you look around here, what is gone? This guy is here, right? This one's the batteries. Okay? The nickel metal hydride batteries find a home. This is what I was trying to do. And I already cut the rods, threaded rods. Guess this what? Ta-da! It has a lock right here. It's not like a lock you can just use like a quarter or flat. You can able to open the box. So this is what I've done, and it fits exactly 24 modules on each side. If I'm able to, I'm taking that because the metal that's suspend. This is where the electrical part was mounted. See the bolts there, nuts. It has on the back where you can hook up, hang this box on the side or on the wall. So I decided the terminals here, I got the tape, the Kempton tape, then I put a black tape on top of it. I put a cardboard here that sits right there, and it jammed really tight fit, just like I knew it. But then I have some knockout conduit stuff and right on the corner right here, so I can able to mount my charge controller, or this is gonna be somewhere I can use like breakers and something else. Or if these batteries were like just any other regular batteries, these are where the BMS is probably come in, or solar coming in to charge the batteries. I was gonna put a charge controller inverter in here, but for the enclosure, I don't want any heat, and it's gonna affect the batteries. So right here I have to make a termination point, or a big hole I have to cut here. I'm gonna put a mount, I don't know, I forgot how many millimeter fan. It's a 12-volt fan that's gonna come in between. See that bolt right there, and there's a bolt right there on the corner, and one on the top right there. I'm not gonna take it, but that's acts like a guide for me from sliding. And these things fit exactly. I can able to build probably another one. I don't know. I might able. Hold on. Before going further, here is the battery here. So we see if we can get another battery in here. I don't think it's possible. It's not. It's not sideways. But if I remove the bolt on that bolt and nut right on the corner right there, I can have this thing to work. I can able to have a third string of 24 module in here. I was thinking about getting about 96 of them total, so I can have a 4 strings of 24s. So right now we're sitting over 2 point something kilowatts on this. I believe so, if I got my math right, or maybe if I'm thinking maybe I'm doing this calculation for other battery, but I suppose this is the one for the 2 point something kilowatts already. But I have to put that on the description below if I'm right. But this is what it is, and this is what we already built here, guys. So here I'm thinking about using the Victron shunt It's gonna be mounted maybe on the corners right here, because this is a metal sheet, and or put it here. Well, I need the fan to be on the side here, an intake and an exhaust. So I'll probably put one back here that's supposed to fit exactly this size. I suppose I have a fan. I have those fans, the thermal control. Go back into my portable gadgets. I think you see it. And have one here with a mesh. Maybe one is pulling and one is pulling. But if I decided to put one here that's already is just gonna be a vent, while we have one up there since heat rises. So this one gonna extract the air. So the fan is gonna be on the top here. I can able to probably utilize a relay. So when I popped it, that air just came out. So this was like a I think it was kind of a control box. This is the AC part of it. So this is where we plug the extension cord and power up all these gadgets right here. Switches. You push this to start, push this to stop, just like for switchboard about something. So doing so, I can able to utilize this guy here as maybe solar input, okay, for the battery, to charge the battery. But I don't know, because these are just a 10 gauge wire, I suppose. 10 gauge wire. I can able to use this for the charge controller. Was inside. I can do the Victron, but I don't want heat because it has a passive cooling system. I don't want heat to dissipate all over the batteries here. And batteries don't like heat. You have to keep batteries approximately 25 degrees C, which is about 76 or 77 degrees Fahrenheit, something like that. So I was gonna put it in here, but that's gonna be the problem. If I have it here, I can bring this. I'm gonna use this wire as a 10 gauge as solar coming in to the charge controller, unless I decide to expand, remove that bolt, nuts, and slide that guy all the way. But this guy is not mounted all the way underneath. I think is a bolt that is welded on the surface, like down here with this box. That's how it is. So now I already get my batteries. I'm not gonna take them out anymore, and I just have to try to configure these guys and have maybe bus bars in here to do my parallel connection. I can able to do, see, I can able to do the series for 24 volt system. It's just a matter of interconnecting the battery. There's a positive here, is a negative. This is a 12 volt battery right here. Is a 12 volt battery right here, 12 volt battery right here, and there. So I can able to do a series for 24 volts, but I'm gonna reduce the amperage. I think a total of 190 something amps total on this right now. So, and the voltage running higher. It's just for the, I want a longer run time, but the 24 volts fine. But if it's 90 something, 94, something like that, and divide that by 2, so we're gonna end up sitting at maybe 45, 46 amps only on these batteries at a 24 volt. So I can just able to wire them easily using the negative from this battery right here and tie it to this positive right here. And we have one lead right here, which is the positive. You have a negative right there, goes to the bus bar. Okay, I do the same thing for this side here, and negative positive goes to the bus bar. So we already linked the batteries. Maybe it's a good idea We don't have to worry about too much wires, while we get one of the positive right here and grab one of these negative right here and tie them together here. So became 24 volts right away. Then we have the negative on this other side, this one here, and the positive here, right here, and I have to do the same thing again. Then we end up having 24 volts, which is a simple connection, but I don't know if I want to use a 12 volt inverter on this one, which is trying to get to Victron. Stay tuned for that. I want to get all Victron for this box. Victron shunt, Victron charge controller, Victron inverter. You know, that's what I want to do. So having this as a 12 volt will be really portable. And I'm going to use, because I have the leverage, I can screw on the corner right here and put it into a cart that has wheels. Okay. A rolling cart, like I can buy it from Harbor Freight and screw it right there so this thing can just coast. So I was gonna throw the inverter in here before because there's an outlet already. I can just build a plug on this guy right here, you know, build a plug right there and plug it to the inverter. From the inverter, this should have been the outputs here going out to power equipment, okay, or utilities. So this is what I've been thinking. I've been saving this box for quite a while, and I want to make sure I use it for the right purpose. But what I've done here, I can able to do it again on the other PVC box I have, which I can able to put probably 3 strings of these batteries there, or maybe less than that. But I can able to have an inverter inside, a charge controller inside mounted, and which probably gonna generate heat. No, probably it's gonna generate heat inside that box. I have to have an extractor fan that's gonna suck that air out of that box, and which is gonna be noisy because I'm trying to keep Victrons with the passive cooling, not the inverter. I never dealt with one before. This is the first time we're gonna deal with one. So I don't know how everything's gonna come to play. But I have all these termination points at the side here, and the box can close really nice just because of it's kind of stretch, kink a little bit from extending, pushing this case. You can see that here. You can see from here a little bit stretch out, comes out towards me. So that's why it's gliding or scratching the box. Well, this is what it is. I just want to show you guys live at the command center of JW Solar USA. This is what we've done, and this is what we want to continue doing as time goes on. And I want to build this fantastic system I always wanted for this box. And I'm gonna try and use some of the controls here. Maybe I can remove these and put a disconnect here, the battery disconnect, to disconnect the battery, you know, the shutdown. Okay, I use that one, and I'm gonna use these holes right here, mount the inverter up here, mount the charge controller maybe on all one side, but I want to keep the weight balance, and maybe I mount here the charge controller. But if I decided to mount it here, the inverter, which I have to buy, and I can use this point here to bring the wires, since the door open, this is the bottom part of it. So I can able to bring from the shunt right down there, smart shunt, it's going to be reading wireless, and maybe I can able to use a dongle on it so that I can put the dongle up here, somewhere up here. This is the top, so I can have a extended range instead of being the enclosure with all the metal frame. It might probably cause you know, interference because of metal and whatever, and it's not gonna work right. So I'm gonna put something here that expand here that blocks this battery from not coming and sliding back and forth. So if the box probably tilts or anything, so I'll put something here. I can cut like a PVC thing that holds it, or maybe a board to hold this exactly, not to come back this way. It's hard for it to come, but you know, it can slide anytime if you know can underestimate physics. So all the wires gonna be coming probably, or anything I want to do later, probably can able to route it on the side, or I can still use the disconnect from the side here. I can use the main disconnect on the side of the battery disconnect. I can able to do that and run the wires across on top of the batteries here, because I can go underneath or yeah, anywhere. So I can put the shunts right there. And the battery, the cable is going to be coming here from the inverter, coming to the shunt to the bus to power the inverter, and to charge the charge controller as well. I'm going to leave these other small holes to bring the charge controller as well. The wires coming in here to charge the batteries, and the disconnect's going to be probably on the corner here or on the other side of these guys right here. Whatever I want to do, I want to put it. And I don't know, since this hole is already here, I just want to utilize that and do something productive. The inverter probably gonna sit here. The positive negative wire comes in here using a seal here, because the edges are really sharp, and trying to protect it from cutting the wire. And this one here, maybe I can inverter here, and charge controller here. I can just use strain relief, put it right here, hold the wires, control everything inside. So the inverter, since this is the bottom, and so flip the charge controller's inverter, the wires comes in here, be nice and neat install. Well, this is what I have for you guys, and thanks for watching. Stay tuned. It's a long video. Like and subscribe. JW Solar USA, live from the command center. Love you guys all, and stay tuned for what to come next on this channel. We have to order the inverter. I'm not sure yet, but I want to use all Victron on this portable generator DIY solar by JW Solar USA. Bye for now.